6.5.12. Right. And assuming the form A is given by sum of n, lambda sub n, E, F. F and G normalized to show that is the same as the 6.5.11, right? If you have A operate on F, then obviously it's n lambda n. Now you already use n, so you use another index and operate on Fn. Right. I think the previous exercise you showed that they are orthonormal. I mean, orthogonal. You showed orthogonal in the previous one, but then you always can normalize that. So that becomes polygon delta. So, and then you sum over m, what you get this this condition, which is the required one, right? So now you want to try the other one, or transpose of A is basically changing F and G, right? Because that's how you do the transpose, right? So basically, this is like you have this Gn. Each one of them is a multiplication of a. This is like a column vector, right? Column vector multiplied by a row vector that will give you a matrix, right? If you reverse that, then and we reverse the order, then it becomes a transpose. So changing column to row, right? So you can say this. Let's just say already you want to operate on G, right? And then A transpose is changing F and G. M, now changing to M. They operate on Gn. Now this is also a conical delta, right? And so that is sum of M, 1n, Fn. Right. Now that's the second equation. I think your textbook suggesting you to do that. The operator is this, like this, whatever the psi or an arbitrary state is given by a combination of Fn. The sum over whatever, sum over Rn is n, and that's n. Right, and then A operate on psi is equals to sum of n is A operate on Fn. Right, and then according to the previous question, A operate on F sub n is give you lambda sub n. Jesus. Right. Then what you want to argue is that this A sub n, A sub n, you can change A sub n by this. This is like you take the scalar part of F sub n to sign. What you get is obviously if it changes to m, it's F sub n, so F sub n scalar part between F sub n and F sub m become delta Kronecker delta n delta mn. The sum over m becomes A sub n. Right. This is just like what the usual formula for the coefficient of expansion. So that's straightforward. Right, and then you substitute this into here. N F sub n psi, and then this is A sub n, and then you have lambda sub n, E sub n, right? And then now you do something like what I said is abusive of notation, but you did it anyway. So n, put this here first, lambda n, E sub n, sub n. And then you artificially truncate this into two and call that operator n. Right. I mean, symbolically, you can say that, something like that. But essentially, this is due to this fact that you use this, assuming A is that, then it will satisfy the two equations that is required in the 6.5.11, right? Essentially, it's the same, but you do it that way, you kind of getting a more law. I mean, follow it a sort of straightforward, kind of like a derivation, but like I said, the last step is kind of just break the rule of notation. All right.